Test? Oh, yikes. Hello, hello. Okay, I think the audio is sort of good now. I think it's in two ears as well, so that should be fine. Let me also just. Oh yeah, the audio, the webcam's still broken. Let's see if I can fix that real quick. Oh, I guess I can just unplug it and plug it back in. So if people are wondering, I guess anybody on Twitch, can you hear me? I assume you can. I think OBS is making it pretty clear that it's all good. Oh no, don't switch there. Okay, maybe my webcam won't work for the beginning, but we'll work with that. Um, so last week we had the Rust graphics meetup, and I think I used all of my technical luck there to make it run flawlessly. And so this week we are back to the Stone Age on some stuff, um, including the fact that I have to use my. Oh, I hope it's not double you doing audio. Let me just disconnect this for now. There we go. Okay, so it's just going to be using my headset. So audio quality is pretty not too great right now. Okay, sound is working on Twitch for now. Okay, that's good. So welcome everybody to the October Rust Gamedev Meetup. Starting off a bit rocky today. However, we do have some cool new changes. We got I started using Restreamable, so we're actually streaming to both YouTube and Twitch. And because of more technical difficulties and the fact that I didn't try to sign up for like the live view of the like on YouTube, like when you live stream, you have to wait 24 hours for them to validate your account or whatever. Then I'm actually using the Veloren YouTube to test it out this month, and so a little bit weird there. But I just had access on that account, and it's set up for live streaming, and so I think it's kind of cool though. Someone in our Veloren admin chat mentioned that it could be a cool idea to try like hosting the meetup on different game dev channels in Rust, and so I might look into that in the future. And if anybody's interested, feel free to hit me up, and we can maybe give that a try. Yeah, so welcome to this month's meetup. What is this? I'm in Carla. One second, let me go over to my slides here. What is this? So this is the Rust language game development meetup, not the Rust game. So if you're here for the game, wrong place, unfortunately. But we still got some cool stuff going on. And so this is an opportunity for a lot of people in the community to show off what they've been working on, to get shout outs about their work, and chat with others about the stuff that they're doing in the Rust ecosystem. And so what I want to try this month is, if anybody wants, they can put into chat what they've been sort of working on this month, what projects they've been working on, and we can I'll just promote some people if anybody wants to say what they're working on. But just dropping a few quick things. So last week we had the Rust graphics meetup. So Kvark and CW Fitzgerald and Wumpf, they all did presentations. Those are all up on the Rust Gamedev YouTube. For Veloren, we had a release last month, and so that was pretty cool. We got a few speakers here who I think have been working on some pretty cool things, so they'll be presenting those. If I don't see anybody else talking about what they're working on, I guess everybody just comes here to see what other people are doing. But um, yeah, maybe next time I'll do this ahead of time so I can get some more chat stuff. All good. So for this meetup, wait, I was supposed to do this here. Okay, whatever. I'm also using like HackMD. Like, I don't know if you've ever watched any of like the Rust Lang meetings, but they all use like HackMD for presentations and for taking notes. And it's actually just superior to every other presentation technology because I can write my presentation in Markdown, and that is super cool. And so, anyways, I digress. We're gonna start on the show and tell. It might be just a few minutes until I get it set up on the audio end and everything like that. So I hope you enjoy the schedule music for the next few minutes. Hello, testing. Oh wait, the Yeti works now. Wait, can I get you to say something?
Hello, hello.
Okay, cool. Wait, I think actually everything is working right now. That would be really crazy.
Awesome.
So, everybody on Twitch, you were lucky to miss out on some like really messed up audio stuff, but it seems to all be working now. Um, and so we'll get started first. So we have Elhemi here to talk to us about Blue Engine, and I'll let you get started.
Hello, everybody. My name is Ilham, and I will be talking about the Blue Engine. So I was actually planning to talk about it last month, but I thought I would be polishing up some things before that. So what's Blue Engine? Blue Engine is a graphics engine, first of all, not a game engine. So the original idea behind it is to be flexible and extendable, and also portable. So the way it means is like during the time of development, you can change anything, any part of it, or work at any level of it. So so I was inspired by the idea of Rust and trying to empower everyone to make good graphics. So this might be just another graphics engine on the market, but I'll try to change your mind on that. So let's start to see how it works. So first of all, this is an example. Let me run that. The very basic thing is drawing a triangle on the screen. So something like this. And on most of engines on the market for the Rust, it will take a lot of effort to draw something similar to that. So let's see how much it takes on the Blue engine. Yes, showing code is bad, but I think this will be necessary. So for us, for Blue Engine, it's just this many lines of code, under 10. So let's dive in to see what they are. So first of all, there is a bit of a classification. So the header will contain like all of the like top definitions of it, structures, enums, and everything else. And then each of them will have their own separate files on that. So we need an engine, settings, description, and all that stuff. First, we create an engine and use the default settings for it. Then create a triangle and then start the window loop. That is everything you need to create a triangle. You can also remove that line and just can still work out a clean empty window. So underlying, it uses WGPU. to render stuff. So I was planning on using OpenGL firstly, but I think WGPU is more stable and very favored right now because of uh, it having a better speed than what I would normally achieve myself. The Blue Engine have been in work since almost a year ago. Originally started on C, then moved to Rust, which was on January 14th, and until now it was under construction a lot. So far, it's version 0.2.5. There's also a small amount of documentation on it, a similar look to the Rust book. The planning for it is to be still being extendable and also flexible and be only a graphics engine. So if you want to just use the predefined things and quickly set up a prototype, you can do that. Or if you want to go and do everything yourself and start from the very basic, you can also do that. You can even work at the vertex stage and defining your own vertices, textures, and everything else. And also, there's a very large amount of settings you can edit and change or however you wish to. For example, you want to have your own version of rendering, or you want to even make your own rendering engine or graphics engine. Blue Engine can help you with that. So this is an example code for that. There's also support for 3D as well. So allow me a second to do that. It has a camera so far. It has yeah, that has a camera so far. It also have the shaders, texture support. It has vertices support to exchange that, and also was focused on speed too. So on my first time, on the early stages of Blue Engine, I tried to benchmark it, and it was able to render around 800 million triangles. My setup is really old, so that was impressive for me. And basically, yeah, that's it. It's still under work, so you can be expecting a lot of more features and extendability on it. And hopefully, until the first release, a lot of bugs and things will be solved. There's also plans for a branch of it to be for a game engine and also an editor for it. There's a lot of things planned out for it. We also have a Discord server which you can join in and speak there. There's a lot of people here trying to uh, solve and help me out on stuff here. For example, Nazwat here. And other than that, yeah, this was Blue Engine. Uh, I think I think empowering everyone to make a good graphics is more important, but also having a starter point for beginners is also important. That's it. Thanks.
Nice. Yeah, this is super cool. I'm sort of wondering when you're going about designing like an engine from scratch, how do you like or what things do you take into consideration when you're like building like the sort of behind the scenes of like what the game loop is actually doing, both from like the perspective of what the developer will do, but also on like maybe an optimization side as well. Like how do you sort of like plan that or consider it?
Original inspiration for the API design was taken from some of the JavaScript engines that are out there, like Babylon. They have a really cool and simple API design. Like there's only one main loop, event loop, and then you create your objects before or during that. So that also allowed me to. If you look at here, there's also a similar thing here. Like there's an update loop here, which you can pass some objects and stuff, and then during that you can update the object. So this also helped to like have events and also control what the loop does or how often it goes, or also expose some other things during that, like delta time or other things, and also live events like camera, like clicking, typing, and stuff like that. For optimization, I've gone about using a similar case to batch rendering, which WGPU also has that, but the batch rendering style is for Blue Engine is basically having a pipeline. What a pipeline does, let me just find the thing here. Pipeline. It's a bit messy here.
Oh, good. Yeah, I remember also like for myself, I've looked at making an engine in JavaScript because I was well, I mean, back in the day when I didn't do a lot of Rust and stuff, but what I wanted to do is make a game engine where you could use Discord as the front end, and then it would give you
Oh,
like the ability to have like a game loop and everything like that. So definitely, I love like the idea of sort of just being inspired by how like there's other examples out there and trying it yourself, and you learn a ton right off the bat, like super easy. So it's super cool.
exactly. The JavaScript really has a good design, to be honest. It's simple and it's easy for everyone to use. It does have uh, parts to be optimized, but yeah, overall it's good for beginners. So the way Blue Engine took that is having a pipeline on the base and having a list of an array of pipelines. And each pipeline has a shader, a vertex, a texture, and a uniform buffer list. So each of them will have your own list. So in this way, you can also cache your data. So for example, you have one shader that you want to use on, for example, a million objects. You can just create one shader and then a million of the other objects and just directly reference that object. So it kind of does automatically caching for that, which really speeds up a lot of things and also
Yeah.
helps with, yeah, it is basically a CPU level instancing and vegetation, something similar to that.
Yeah, that's super cool to be like sort of working that close to the hardware and being able to experiment and stuff like that. So, yeah, not bad, not bad. I hope we see more improvements on this in the coming months.
Thanks. Is there any questions about the Blue Engine?
I don't think there's any more, and if there are, then they can just be in chat. Awesome.
Everything.
Well, thank you very much, Elham.
Thank you too. Have a nice day, everyone.
So welcome back, everybody. I have a few shoutouts that I just want to do first. So this month, All Edge has been working on updating the Rusty slider with code execution for a few languages, and they've also been working on prepping image support. And then also, this is a pretty cool one. So Albin at Jovian Entertainment Studios was sort of discussed to me about how they're working on a sci-fi 3D exploration game, and sort of like, so they said specifically sort of like Dyson Sphere Program, and I love Dyson Sphere Program, so I'm very excited to see where this goes. Now, Connor, who's going to be presenting in a bit, might also be excited to hear that they're using Ren 3 and eGUI for the graphics, and so and the game is based on Bobaverse, and so Albin, if you're here in chat, you can, if you just drop in it like any links to Discord or anything in chat that you want, That'd be very cool. But I'm very interested to stay up to date with this progress. So next up, we have Ekton here to give us an update on where Cosmic Verge is.
Thank you. And I also have to say that that was sounds down my alley exactly. I've been playing Dyson Sphere Project the past
It's
week.
real
So,
good.
yeah. So, what is Cosmic Verge? It is eventually going to be a 2D systematic sandbox MMO. But as you're going to hear, this is basically I presented the game back in February initially, and ever since then I've been rewriting a lot of underpinnings in Rust. Part of a way to hopefully simplify deployments as well as to figure out how to scale ourselves more horizontally when we eventually, build this MMO. So. This is the architecture so far, and the gray boxes are the stuff that we haven't actually touched in the past month. Our main focus has been on what I started talking about last month, which I'll go into. And then technically GUI, our UI framework, has seen a little bit of updates, but it's only been the last couple days. And you'll see the little tool that I built that required a couple of small updates for me to be able to finish up. So what I presented last month was I called it BonsaiDB Roots. It was a project to replace SLED in BonsaiDB, which is our database platform that we're actually going to be using to build our entire architecture with. And last month, I was about a week into development, and it's meant to be a key value store written using an append-only file format, which is kind of a fun, interesting challenge. It is inspired by something called CouchStore, which BonsaiDB is inspired by CouchDB as a database, and CouchStore is the implementation of its actual file system. And so I stole its ideas on how to do an append-only B tree and started going to try to write it. So why write Nabari? Well, last month I talked about a bug that in the end, after I finished swapping the Nabari out, sled out for Nabari, the bug was still happening on my Mac. It was only a bug that I could experience on my MacBook M1, and it was really weird. And in the end, it boiled down to a bug inside of our code, inside of connection handling in Fabric, which I'm going to try to sell you on in a little bit. So, the bug ended up just being a simple async task bug where one task didn't properly shut itself down in an error situation. It was relying on some other signal to send it to say, "Hey, we're actually disconnected." That signal wasn't actually making it back for some race condition reason, and it was causing a unbounded channel to pile up a ton of memory. And it only seemed to happen when I was spamming the database, but it turns out it wasn't actually Sled's fault. So why continue to write Nabari? Well, Sled is a very complicated project if anyone's ever actually tried to dig into it. And um, one of the selling points of trying to do everything in Rust is that there's a lot of the infrastructure you can actually understand and poke in yourself. And Sled to me felt like a big black box. There's a lot of unsafe code. There's a lot of crazy stuff in there that makes it very fast, as you'll see in a minute here. But I had a library after a few weeks that was, no unsafe, handled lower in memory environments well. There's the current benchmark suite that I'm going to show you a couple of snippets from. I can't actually run Sled in some of the same VMs that I can run myself in SQLite in. So it's clear that I have a little bit better performance on these kind of more constrained environments. And then the biggest selling point to me is that I can custom fit it to BonsaiDB's needs. Things like the transaction log that I need to be able to support for replication, things like that. Technically, it was just extra work that I was doing to build it on top of Sled, whereas I can build it into the fundamental how Nabari works for myself. So, and then part of it, not the threading stuff, can be supported on no standard in theory, which would be kind of fun. I haven't written a library for that before. And yeah, it's fairly recent and performance is pretty good. All these graphs are done using Criterion, although I actually copied the results into a spreadsheet application to make the charts so you could see multiple benchmarks side by side. The top two lines are Nabari, which the plus indicates that it's a full revision history save. So in that particular tree, you can see all the edits to every key until you compact the database. And obviously that requires a little bit extra IO, so it's going to be a little bit slower to do. But basically, inserting in Nabari is really fast compared to both Sled and SQLite. Retrieving records is pretty good. SQLite, as you'll see in pretty much all the scenarios, is very steady in its performance. But the cool thing is that Sled and myself, Nabari can actually kind of exceed it in many cases. Although in certain cases, like when we get to larger data sets and we're scanning lots of rows, currently SQLite actually exceeds both SLED and Nabari. So the takeaway from these benchmarks, are there's a couple of things. One is something I mentioned last month, which is that compacting a database is required to reclaim disk space when you're using append-only files. So there's going to be a lot of bloat on disk if you don't do that. And essentially, the insert performance you could say is trading kind of current speed for how fast I am inserting the data for potential future I/O where you have to compact the database in the future. So that's really, really hard to actually write benchmarks that showcase what that really looks like. So at the end of the day, you always need to benchmark, your application, not just trust micro benchmarks that anyone throws up on a screen somewhere. That being said, I do have it fully documented, and you can go poke around at our benchmarks and stuff if you're kind of curious. So I am pretty happy with where Nabari's at, and I'm almost done to the point where I'm gonna just kind of finish working on other stuff. So Dax, the other contributor, Dax Peta, has been working on Fabric updates. As part of looking at BonsaiDB as a platform, we kind of identified that if we wanted other people to use BonsaiDB as a game database, essentially, we'd want to support unreliable delivery. And so that's one of the things that he's been investigating is not only having our reliable payloads delivery that we currently support, but also adding unreliable datagram delivery. But with Quick, it still will have built-in TLS on top of that. So you get a lot of the benefits of the Quick protocol while still being able to do things like use unreliable datagrams for things like voice communications often, but also like positional data that is getting spammed at the player essentially, that it's okay if they lose some of it because the next packet will kind of allow them to proceed forward. And the other thing that we're doing is we're going to be looking at WebRTC support for the browser. We believe that we're going to be able to pull off the ability to just flip on a feature flag and your socket will automatically be able to handle WebRTC and Quick based connections over the same port using the same TLS certificates and everything. It's still early in development, so that's not a promise. But the idea is that if you were to start using Fabric in the near future, over time you'd be able to just flip on a switch and have browser support for unreliable datagrams as well as reliable. So that's where we're taking Fabric, and I'm pretty excited for what that means for the BonsaiDB platform as a whole. So as I said, I'm going to continue finishing up Nabari. We're going to work towards those Fabric goals, and then ultimately we're going to start building what will become the in-game chat for Cosmic Verge someday. There's going to be a lot of other steps, which is why I've resorted to putting a little filler in there, and eventually we'll get to writing the game. Here's a bunch of links for how you can chat with us and interact with us. We'd love to have more people join part of this journey of making some pretty cool development tools.
Awesome, good stuff. I always love seeing the Cosmic Verge updates, especially when they come very very technical in
I
form
forgot
and
that I
stuff.
actually had this tool
Oh
as
yes,
well
that's right.
that I
Yes, talk
wanted
to
to
us
show
about
off.
this.
Yeah. So I started building this a couple days ago to try to help me understand the file format because actually be able to describe it right here. In this particular graph, the performance of Nabari drops off horribly for sequential record retrieval out of a data set of 10,000 rows. But if you look at it, the random data set is still actually really fast, but the sequential one is really slow. And I had some theories, but without being able to like really visualize the tree format, it was really hard. So I'm gonna sit here and just add a bunch of numbers. And what you're seeing at the very top is that the node position of the root, the very top one, is continually increasing, and it's because we're in a append-only file format. And you're also seeing some of these other nodes get updated too, but some of these other ones aren't. So what this means is that when you're adding new nodes, you're actually updating only part of the tree as you go. And the problem that you're seeing in this particular benchmark is that the tree is growing too deep on sequential inserts, which means that when we're doing gets, there's more jumps that have to be done on disk. So my algorithm for how I determine how deep the tree should get based on kind of or it's actually not how deep, it's how wide, how many nodes you can have at each level, is not optimal. Despite that, I'm still doing pretty good. But yeah, so um, this is kind of a fun little tool that I built over the last few days. So
Yeah, and so when you showed me the picture of this, I'm like, this is super cool. I love this idea of being able to like sort of introspect or like just like look into whatever type of data and play around with it. And so, is this using eGUI or ice
no, this
or
is actually using my own GUI framework, although
not bad?
technically this is just a canvas drawing a bunch of stuff. So it really could have been used any 2D renderer at that point. So
Yeah, but I mean, still a really great way to go about debugging. And then I suppose like when you're like looking at this and stuff like, would you make this into maybe like a more like fully formed tool as like something to accompany Nibrari, or is it more just something that as you're developing yourself you'll be able to use?
I think it's more of an educational tool because, one of my selling points in Nabari is that it's easier to understand and maintain. And I think that having this tool can help me uh, teach people how it actually works because an append-only B tree is kind of weird, but it's honestly pretty straightforward and simple once you kind of understand the basic concept. And I think that
Hmm.
this tool will help you understand how it actually functions much easier. So I see it more as
Yeah.
an educational tool for potential contributors to understand the project better.
That's like a super great idea. I love that sort of approach of, and especially since a lot of algorithms, once you get down to like what they do, are actually quite trivial to sort of walk through. And so, yeah, having this as some accompanying way to think through the logic and allow people to find their own analogies and make it to the ability to be able to contribute is a really great way to go about it. Um, I also want to add a quote in here describing some of the development problems as some race condition reason. Very naughty, making those safe deadlocks in Rust. But anyways, I just thought that was like a funny statement. But thank you so
Yeah,
much, Ekton, for
absolutely.
showing off Cosmic Verge updates. Oh, actually, one more question I did have. So at the end there, you did mention like a rewrite of parts of Cosmic Verge, and so now that you have like a lot of this tech that you've been working on, you mentioned that you'll redo the chat. But what other either improvements or complete overhauls do you see a lot of Cosmic Verge going through with this new tech?
So the dirty little secret is I don't know how soon I'm going to start Cosmic Verge. That's one of the reasons why I put the dot dot dots. Part of the Bonsai DB vision is a very modular architecture, and so we are envisioning the ability to have that chat be a standalone application in and of itself,
Mm-hmm.
and be what we build on top of as a
Oh.
general purpose framework to start building chat enabled applications, which will eventually be Cosmic Verge. So that does sound like a very lofty goal, which is why I haven't really been trying to pitch it on the slides yet. But that's a preview of where we're going with the platform.
Okay, nice. Yeah, that's a pretty good outlook on it, I think. Yeah, so I guess in the next few months we might see some more updates from here as well. So thank you very much, Acton.
Yeah, thank you.
Okay, so next up we have Connor, CW Fitzgerald, who is here to talk about Ren 3 V2.
Yeah. So, welcome. I am CW Fitzgerald, or Connor, or that parrot guy. And I'm here to talk about my 3D rendering library, Ren 3. I've talked about it before, but as a reminder, it is a 3D rendering library that's designed to be very easy to use, customizable, and efficient. And we've been both me and a bunch of other contributors have been doing a lot of work on improving things, making things better, and we are happy to celebrate that. Not right this second, but after this meetup, there will be a 0.2 release with all of these new fancy things, including we're now based on WGPU 0.11, which just dropped, on Thursday. We now have the ability to have fully custom materials. We fixed shadows, made made it so that you can have custom camera transforms. Before you couldn't like roll the camera or do anything like that, but now you can have arbitrary view matrices. GLTF loading has gotten a lot more robust, including supporting loading from compressed textures and uh, allowing you to split up, so you don't have to load a whole GLTF file. You can say, oh, only load the meshes, only load the textures, whatever. As I talked about at the graphics meetup last week, there's massive performance improvements, especially with scenes with tons and tons of objects. And we're now offering Scene Viewer as a standalone application that you will be able to go on Cargo and just install if you just want to view a GLTF or something like that in a very pretty fashion. And without further ado, I'm going to shut up and show you a demo, because all of my presentations before have mainly been me talking, and I want to show you things. So, this is loading up some of these various large sample GLTFs. It's going to take a minute because all of the images are PNG files, and PNGs are really slow to open. You can see the progress going there. It always takes longer when you're live on stream. All right. So now we have this big scene. This scene has about 20 million vertices in it. It's being rendered 4 different times, because let me make this full screen. There we go. It's being rendered 4 different times for the various shadow cameras as well as the depth pre-pass. And one of the biggest things with this release is that shadows have been fixed a ton. You no longer get that shimmering that used to happen when you moved the camera. And also the various bugs in shadow mapping have been fixed. So this is the scene I used to stress test because it is such a big scene. There's about 50 million objects here. You can actually see there's some Z fighting going on often in the distance. This is actually because this model has multiple different levels of detail for every object, but because GLTF doesn't have a great support for level of detail, I can't actually detect that right now. So I'm just rendering everything, which means that I have multiple objects right on top of each other, which is what's causing the Z fighting that's there. So this is just one example. I'm going to move on to, if you don't know, NVIDIA has something called Orca, which is a collection of FBX like scenes that are big and useful to test with. So I'm going to be showing you at least 2 of those. This is the bistro. I don't know how you pronounce that. This is also often used for testing rendering. You'll see it in a lot of papers because it doesn't have that many. It's not that intensive, but it still does have 30 million sorry, not 30 million, 3 million vertices and stuff like that. And once we show off these examples where we have actual real geometry, you can start to see how things like shadow mapping are actually really hard. I don't think it actually comes up in this map here, but it's very easy to, like right here. You see how the bottom there has a lot of, there's basically light leaking through here, and that's an artifact of shadow mapping being actually very difficult to do reliably. And of course, I'll be working to fix those and try and limit the amount of artifacts you get in all the common cases that you're likely to come across. So, yeah, this is that. I'm going to move on to the one I just discovered, which is the Emerald Square, which shows off another really fun quirk of how difficult 3D rendering is. And part of the reason I'm willing to come and show you things that aren't actively working is sort of to prove a point that doing 3D graphics reliably is actually really difficult. And that's basically the use case my library is trying to solve, is that for people who don't want to deal with all of these weird quirks about how shadow mapping works and how, you know, the fact that there's various different types of normals and all this stuff, and they just want to render things on screen in a way that is fast and efficient, I'm trying to solve that problem for them. So here's an example of fun, especially when dealing with random models. You see these hedges, I guess, and they're actually not being rendered in the right order. The reason being is that the model file that took them from actually has every single object at position 0. It just has offset the vertices way the hell off into wherever they're supposed to be. So I sort the depth of all of the objects to make sure that I render them front to back when I'm doing transparency. Except I think that all of them are in the same location. So there's no sorting that I can actually do that will work correctly. So you have to take into account that and actually use the center of the mesh's bounding sphere. All of that thing is stuff that most people probably don't want to deal with, and this is why my library exists, so that people don't have to worry about that kind of thing. I particularly like this one because it really does show all of the different weird things that can happen when dealing with 3D graphics. We see, the shadows are a little weird. Shadow mapping is most of the problem, fundamentally. This is why, ray trace shadows are so cool, if only they were not so expensive. And yeah, I think that I have one last thing to show, which is the Sun Temple. This is going to look a lot better once we have support for point lights and what are they called? Light probes. Once we have support for light probes, this is going to look really awesome. Right now, we have an ambient lighting setting that is being set to make sure these don't get full dark. But once we have light probes, we'll really be able to see how bounce lighting and such would work. As you can see, there's very nice. The light coming in from the sun looks very nice, shining on the statue and peeking through the various windows up there. And yeah, this is a very good indoor test scene. It's kind of similar-ish to Sponza in terms of what it's useful for. But yeah, that is Rend 3 in practice. So it does actually work. It has, of course, some bugs. We're aware of a lot of them and will want help with them. Let me go back over here. Just to go through some of the notable changes of late custom materials, every render list can now define its own materials, what it means, and all we care about a material being is a set of textures and a set of data. We put that into your shader, and you can just do whatever. Modular GLTF loading, as I mentioned before, you can now only load part of the GLTF and load them in custom ways so that you don't have to throw away a lot of the useful, low-level code, like load an image and like do feature detection and map texture texture formats and stuff like that. But you can still do custom loading. In addition, this is mainly from our graphics talk. Lots and lots of CPU side performance improvements. We're talking anywhere from 5 to 20 times, depending on how many lights you had. And more performance increases, especially on the GPU side, are coming soon. So this, as any library that is currently in progress, a lot of the selling point of it is what it will be, not what exactly it is right now. And this is vaguely in order of what things are going to go. Most of these I hope to get out for the 0.3 release in a month. We're going to have a render graph so that we can you can compose render routines. We have a concept of a render routine, which basically is the thing that does all the rendering. We provide a default physically based rendering based render routine, which is doing all the rendering here. But obviously, games need support for custom shaders, custom objects, and that this is the way you're going to be able to do it. You write your own render routine, and you just stick it in the render graph after the PBR routine, and you can you don't have to rewrite code, and you can add your own stuff to the thing. In addition, eGUI and ImGUI render routines to automatically render that inside the render graph. Shadow map customization. Currently, there's just a single, for every sunlight, there's a single shadow map that is following the character. We want to do cascaded shadow mapping, as well as allow the user to customize shadows to a higher degree. And validate that our PBR impl is right, start on point lights, and do GPU side optimizations. So what you see now is just a fraction of what it will be. We are making good progress. The biggest thing, and the thing that I want to invite all of you to, is that we now have a dedicated chat room just for Ren 3 on the Matrix. So we no longer have to go and spam the WGP random chat room anymore. So there's a link there. There's also now a link on the Discord in the beginner facts section. So please come join, have a chat. Love to talk with you about either contributing or using the library or just to hang out. Finally, how to start, documentation, repo, etc. If you have questions, please just find me on Discord or come to our new Ren 3 matrix and have a chat. I think. Nope, that's not what I wanted to do. Finally, acknowledgements. As always, I cannot do this without all the help of all the contributors and people who have given me ideas and direction. Scooper, Noxum, Mindswipe, Albin, you've all been great. I look forward to keep working with you, and there's many more who I am not mentioning. And if you want to help out, tons of stuff to do. Come over. Ta-da!
All right, nice. That was a pretty thorough update of what was going on. And I like the demo as well, kind of seeing some of the wonky stuff. I think that's like one of the most important things. Is like you can often see you can go check out like a show reel or whatever and see what everything is good, but when you actually have like the developer going through like what's there is still to improve, I think that's some really cool stuff.
Yeah, hopefully all of my presentations from now on will just be live demos.
Yes, that's a good way to present.
Yep.
So one question from chat. So Daxpeta asks, I know there is like this issue that's already on Run 3, but now with WGPU 0.11, are there any thoughts or progress on WebGL support?
Right now, no. WebGL is currently actually below the. It supports less things than my support everything thing needs. The main thing you're losing is storage buffers, and it's very, very hard to do. It's very hard to do what we're doing without storage buffers. It can be done, but it means that we have to completely shape how a lot of the data gets transferred. And I already do this between the GPU called mode and the CPU called mode, and adding a third mode is something I'm not particularly keen on. I wouldn't be completely opposed. On the other hand, I think this is one of those cases where web GPU might be ready before I could actually get. Oh, is my audio dropping out?
It sounds okay to me, Cape Reed. I think it might just be on your end,
Oh,
unless
okay.
Twitch is like that. But I think Twitch is fine.
It's all good. Yeah, so I think the solution for WebGL may actually just be to wait for WebGPU to be out, because I can run fine. I should be able to run fine. I can't test it because of the instability of WebGPU right now. But once it stabilizes, um, we should support web GPU fine.
Yeah, makes sense. And then another question by Dexped, the classical question: any thoughts on ray tracing in Ren 3?
So, there will be ray tracing. It probably won't be what you think ray tracing will be. Probably not RTX or sorry, not RTX. Whatever the DirectX one is called, DXR. Because no hardware ray tracing likely for a long time. Supporting that in WGPU is a massive project, and for one, I don't actually have a ray tracing capable card, so I can't actually build any of this. But on the other hand, there will be a lot of techniques that use ray tracing in a more traditional way. So screen space reflections, stuff like that. Those are all ray tracing based, but those are all classical compute shader based. So I will be doing that. I'm not opposed to it. Like, there's nothing that I would say that I wouldn't say we would never do ray tracing in Ren 3. It's just the amount of work required to make that happen is so massive that it's so far down the line that I'm not even thinking about
Yeah.
it.
Yeah. So if someone were to come along and implement it themselves, you'd let it in, but until it comes up on whatever feature list down the road. That's
Yeah,
fair.
100%.
Yeah. All right, yeah, so I think that's it for questions. So I'm awesome to see Ren 3 moving forward and some projects using it and stuff like that. And especially, like, I mean, you know how interested I was about the performance metrics you showed at the graphics meetup last week. So if anybody hasn't seen it yet, go onto our YouTube channel, Rust Gamedev, and check out Connor's talk there. It's some pretty intense performance review on CPU stuff. So thank you very much, Connor.
Yeah.
Okay, hello everybody, welcome back. Okay, I'm just gonna check my audio here. It looks good for now. Oh yes, claps in chat, of course, for Connor and all the previous presenters. Oh yeah, and for all the previous presenters as well. If you have links, feel free to drop them in chat so other people can go check out your Discord and your Matrix and all that good stuff. And so finally, I'm going to talk about Veloren. I did just want to add another shout out. Who didn't ask specifically for a shout out, but eBoatwright said all of these are really cool presentations, but I'm gonna get back to working on my Rust text adventure. And absolutely, we love seeing all types of Rust development. It doesn't have to be like the most flashy graphic stuff. It's all about the entire ecosystem. And so maybe in the future we'll see your text adventure, and so could be cool. So I'm gonna talk a little bit about Veloren. Last month I did like a little play demo, but then that day we had our 0.11 release. Let me actually see if I can pull up this nifty looking poster I made. Check this out. Look how cool that is. Wow, 0.11. So we made a trailer as well. I don't know if I play it, I probably won't have audio, so I'm not gonna even try. It's just some pretty cool music. And so yeah, we had someone make the trailer. That's really awesome. Massive change log and stuff like that. But what I want to talk about today is the release party. And so I wrote about this in our weekly blog a few weeks ago. And so if you want to read the whole thing, see everything that was going on, read like all my description of everything, go to just veloren.net, and then this is number 137. I can actually just drop that in chat. Easy peasy. Cool. So yeah, if you want to check that out, go take a look. But what I want to go over is some of the metrics that we had. And so we use Grafana to aggregate all of our data that we have from the main game server. And then on the main game server, we have it exporting a lot of Prometheus metrics. And so some very obvious stuff. And actually, this is a public dashboard. And I don't want everybody to go and try to hit it up right now because it'll take down our server. It probably won't, just fine. But anybody can go to grafana.veloren.net and see a lot of stuff. You can go see Airshipper. You can see that every day there's like 1,000 downloads of Airshipper, and so I guess if I go here and I go to whatever cool stuff we have, K8s, I guess might have some stuff in there. Oh, translations. This is one I haven't actually checked this out very much recently. Oh, this is actually so cool. So we made tests recently where you're able to see what has been done the most in or like which ones need the most work. And so for example, right now, like not sure which one this I think is that or so we got like Portuguese, we got Dutch, I guess, and a lot of other stuff. And so this is how many translations are missing for each of those languages. Unused keys. And so I suppose this means like in Japanese someone wrote a whole bunch of stuff that is no longer needed. But anyways, so my point is we use Grafana for a lot of stuff. It's pretty cool what types of dashboards we have, and we're exposing it all to the public. We want it to be very open. All of our data that we have like going down the road is always going to be in blog posts. It's always going to be out there. And so what that means is that we also aggregate a ton of data on the game itself. And so while the server is running right now, we can see that we have like 60 players online. We can see how well the server is doing. Like the server tick shows, like for example, each tick that the server has, so about 30 per second, what is taking or how much time is it taking. And so for example, this tick took 61 milliseconds, and nearly all of that was state. Actually, this is kind of cool. So I'll get into this in a little bit, but during the release party we had the largest system was actually like entity sync. So what happened is after, as far as I remember, but after our tick finished and it needed to send all the information back to all of the players, it was doing that on the main thread. It wasn't parallelizing that properly, and so that was taking up quite a lot of time. And we'll take a look at that. But now it seems that it's not even there anymore. So this is very cool. And then also, so the thing that I don't understand is normally we'd have physics as like one of the top few. So I wonder if that's bundled in a state right now or something like that, because that's very suspicious that it's not there. Yeah, okay, look, so physics right here, if we take like a look at total CPU time burned by big stuff, physics is taking like 152 milliseconds each tick. But that's parallelized across 8 cores, I think, in the current server we're running it on. So essentially, this is like our main game server that we leave running all of the time. It's like 22 euros a month on Hetzner, I think. We can see like our bandwidth, we can see a lot of information. This is pretty great for being able to diagnose where we can do optimizations. And historically, it's been a lot of physics optimizations. It's been a lot of network optimizations. Like for now, each client is using about 200 kilobytes or kilobytes per second of bandwidth. We want to reduce that. We want to make it so that we're like really taking use of the parallelism that we have on multi-core systems. And so yeah, there's a few metrics that we want to do really well. Of course, like tick time, we want to be as low as possible. And so historically, when we had a release party, it used to be like maybe like the first few were like 30 people on the server. Oh, that's so cool. We could have 30 people on the same server. And then it started going up. And I remember the one release party we had, like I was either 80 or 100, and all of us admins and core developers, it like blew our mind that first of all, our server could handle that many people, and second of all, that many people would play the game. And so since then, we've been trying to like just keep breaking this record. But at every release party, every step along the way, we've always had difficulty when it comes to making sure that we have stability during the release party. And so this means when you get up to the top, like this high number of players, making sure that we're trying to reduce the amount of anomalies that we'll see, especially because, like, for example, we didn't see that the entity sync was an issue until we had our like maximum number of players on the server, because we don't see that issue when there's like 20 players or 60 players or whatever. Same thing with a lot of physics stuff. We had like a lot of interesting networking problems as well. Well, I mean, of course, if you're running with that many people. But an interesting one was that I think TCP disconnect or something like that was running into issues where someone would disconnect and it would hang, and then it would deadlock a lot of other stuff, so then other people couldn't connect and it would just freeze up, and so we had to reboot a couple times. And I feel like that was more of an anomaly than anything else, but it's stuff that you can't really catch until you have that many people. Yeah, and so with our most recent release, we actually broke our all-time record. I think our last one was like 131 people on the server at once. And at our 0.11 release, we had 181 players on the server at once, which is like absurd. Like that many people running around the world, exploring, checking things out. And so to take a look at some of these graphs here. So this is like where the player peak happened, which let's assume we must have started the release party. So this is one of the testers. He took this screenshot. So I guess his time is probably 2 hours ahead of UTC. So I think this was like when the release party started at 8 o'clock here. And so we hit our peak a little bit after that, about 20 minutes after. And what we can see is that our server ticks, even up to the point where we had the maximum number of players, we're still within reasonable bounds. And so anytime that a server tick takes more than 33 milliseconds, then it means it's going to be pushing the next server tick to take longer as well, because if you divide 1 second by 30, you only have, you get 33, and so that's how long you have for each tick. And as far as, so I'm not 100% sure on this, but as you go into like the higher and higher numbers, then it is able to produce fewer ticks per second, but then it's also snowballing down the hill of, if I have to get work done and I'm not able to in this allocated amount of time, I'm going to start spending future frames doing this work, which means that I might not be able to get to updating players and so on. And so that's when you see a lot of rubber banding. We've had this this issue where if you have like server side physics, like you might like run forward quite a lot and then get like teleported back, or like just like in the airships in particular, it wouldn't do proper collision detection against you, so you could like fall through the floor. And so a lot of really nifty issues here. And we can also see like on the CPU chart down here, we have, and so with this release party, we reserved a cloud instance on Hetzner with 48 cores, or 48 threads rather, but it is a dedicated, like you get those cores yourself. And so it worked super well. It's like this new, like their new AMD line. And I did some tests and I found that like there are Intel like servers that have like 32 cores or whatever. If you stack that up against the AMD version, like they offer like the Intel version, AMD version, you choose whichever you want. They're the exact same price, but you get significantly better performance out of the AMD one. And now granted, like the test I was doing was like calculate how many primes you could do in whatever seconds, like whatever like the primes test command is or whatever. And that's not like a super reliable test, but it's kind of or it would seem to me to be more conclusive when it says it's like 30% better than Intel or something like that at the speeds that it's able to do. But regardless, we've always, like from the point that we were able to, we started hosting our release parties on the AMD EPYC ones. I feel like it's just a newer architecture than the Intel one, which might be a few years older. And so what we see here is that even though we are receiving like high tick rates, and so for example higher than 33 milliseconds, our CPU parallelization is sticking, or rather our entire CPU utilization is sticking around like 25% of full capacity. And so what this implies is that our main thread is the one that's having difficulty completing all of the tasks that it needs to within those 33 milliseconds. And so any work that we need to do on the on like decreasing tick time would be specifically trying to get as much as possible out to other threads to work on, and dealing with any potential issues that might come with like over asking like other threads to do work or waiting for stuff to come back or whatever. And so this is always like the game that we want to play. Like our goal for like our internal goal sort of in Veloren's like admin chat is we want like a server that can handle 1,000 players. That's like what would be very cool. And this is like one server on its own. It's not like a cluster of servers or anything like that. No, and I don't know if this means that you can have 1,000 players in the same village. Like that might be a lot of optimization, especially around networking. But anyways, networking wise, we have I don't know what the bandwidth was, but I'd imagine it's probably like, but I think it's about 50 megabytes per second at peak. Server memory is actually crazy. Like at peak, we're at like 7 gigs of RAM used, and this server has like 128 gigs or something like that. But let's take a look at some of the editor images here. And so this is like a breakdown of which systems are taking the longest. And so what we see here is that the physics system and the message, like the terrain generation system, these are taking like very high amounts of time each tick. And so 252 milliseconds on physics and 523 like combined milliseconds across all cores. And so a lot of work goes in here, a lot of work in the agent system as well. So this is like world simulation and just real-time simulation stuff that's happening. But then also we can see here there's entity sync. That's like, in comparison to these other ones, this is incredibly small. But the main problem is that it's running on the main thread. Or it's taking up time from the main thread where it should be passed to other places. Here's the image of these slow systems. And so as we can see, entity sync is at the top at 26.6 milliseconds at peak, or around peak. And so this is like taking far more than it should with that many players, and is significantly higher than every other system. Like even physics is only 10.9 milliseconds. Terrain is only 9.8. And remember, we want to try to stay below 33 to keep the tick rate that we want. And so this was, I think this was fixed recently, especially since we can see on our Grafana that it's like not even on the charts anymore. And so that's sort of like the constant battle that we have there. Okay, yeah, so transmit at peak was about 40 megabytes per second. And so just to add in here, when it comes to like networking in the data center, we have like I feel like it's a gigabit, but it's not necessarily dedicated, because since we're still on a cloud instance, if like the CPU we're on is like whatever 48 times 2 is, if it has that many cores, then we might be sharing our like dedicated cores with on the same host as someone else using dedicated cores. And so I feel like we share the same gigabit connection. But in the long run, if we were to have like many players on the server at once consistently all the time, then running these servers with like dedicated like gigabit, or either like gigabit or 10 gig. And I mean, this is just like speculation, but I'd imagine we'd start looking into systems where we could have sort of like other servers in front of our main server that would act as proxies. And so there's like a cool project that Embark was working on with I think GCP or something like that. And I forget the name off the top of my head. If someone says in the chat, then I'll read it off. But this system allows you to like put this type of UDP proxy in front of your servers, and so it can, like, for example, let's say like you get DDoSed or you get a lot of clients like sending incoming connections, then from the internet you can have 10 instances that each have gigabit receiving all of this data, and it wouldn't bog down the main server. And then over LAN it can probably do 10 gigabit a lot easier, and so essentially you can move the throughput up to probably that much. I'm gonna Google it. Embark Studios GitHub. I don't know if I'll see it like right off the bat here. They have a lot of projects probably. Embark Studios, GCP, Net Proxy. Let's see. Quilkin. Yeah. The first time I read it, I didn't understand the purpose of it. But then I read it a second time. I'm like, oh yeah, okay, it makes so much sense that it could be like a sort of distributed proxy in front of your server. But anyway, so I think that's it that I have for Veloren. I'm just reading chat here to see if there's any questions. So Zester mentioned, although the terrain sync system is parallelized, so that's not so much bottleneck in practice. Oh yeah. So a lot of stuff that we do is like of course, like, you don't want to over-engineer stuff, and we're trying our best to figure out where stuff can be improved, but there's like a lot of like thought and process that has to go into imagining what stuff can be. Entity sync has been parallelized, yes. Okay, yeah. So I think the other day I know that there was like someone reverted some stuff with it, but it's great to hear that it was able to get resolved because and again, like, it'd be like, I want to try and come up with a system where I can, like, on my home server that has like a decent amount of cores, I want to simulate like more and more players on the server, and especially it's like if I have 2 VMs running on the server, then the throughput, if it doesn't have to actually go out to the network, is like much more than 10 gigabit. And so since it's just talking to like the board, but it can still simulate like hopefully like hundreds of players. As Esther mentioned, Veloren might be decent for that. I think, or like the way I was checking it out is that I could boot up like the client and then just, well, I mean, I'd have to do some stuff in the code, but then just simulate me having like 100 connections or something like that. Or I don't remember exactly what it was, but there was a way to, or there was a way that I was exploring. Oh yes, and sorry, I should also add, Veloren is like a command line interface front end for Veloren that Ancestor has worked on. But instead of like having like our 3D graphics fancy stuff, it can just instead be yeah, command line kind of stuff. All right, I think that's enough for my rant on Veloren networking. In the effort of time, I'm gonna just not worry about. Actually, I could just move on to. Oh, this is perfect. We're not even going to go to the schedule. We're going to go right to announcements. I also, yeah, so I'll just mention in here quickly, Kevin from Graphite just mentioned that there's no Graphite update this month. They've taken a break from like the regular monthly stuff just because they've had a lot going on, which is totally cool. It's really good to be aware of burnout and not putting in too much work and stuff like that. And oh yes, that's right. If you're interested in contributing, well, I mean, I should have. Well, let's say in the announcement section, I had a slide on Hacktoberfest. Hacktoberfest is going on right now. I'm wearing my Hacktoberfest shirt, but I don't want to take off my sweater. So if you contribute 4 pull requests to any repos on GitHub or GitLab that are participating, then you get a super cool T-shirt and some stickers. And so any of the projects that were mentioned today that are open source, and so I know Veloren's participating. It seems like Graphite is, and then probably several others. You can contribute to those and yeah, take part in Hacktoberfest. Kevin also mentions, I'm also beginning work on rendering simulated raster brushstrokes in a resolution agnostic way. That'll play a big role in the raster aspect of Graphite, and I'm pretty interested in that. Sort of like the concept of when you're dealing with like Photoshop, you always have, well, I guess I don't know if it's like Graphite's supposed to be entirely vector based, but with Photoshop you'll have like a certain amount of pixels, and once you get down to that pixel range, you can't do anymore. But I think what Kevin is saying is that when you're doing brush strokes, you'll be able to infinitely zoom in as if they were like vector drawings, I'd imagine. But Kevin's typing, so I think he'll correct me if I'm wrong here. Acton says he loves these graphs. We love making these graphs. Grafana is amazing, and having telemetry, like we have so much telemetry, like it'd be silly for us not to do this much. So Kevin says exactly, not hard edges, but infinite scalability. Yes, and so yeah, you get like that sort of vector characteristic to the brush strokes. Acton says he hasn't opted into Hacktoberfest, but he's interested to if anybody wants to contribute to anything that is part of Cosmic Verge. I suppose all the database fancy stuff in there as well. Oh yeah, so Graphite 0.1 has been delayed a little bit. Website will probably go live this month. And yes, I think one thing that I've seen from several people that I've hit up is like, just there's like a lot of pressure by me asking if they want to present, and so definitely, like, if people aren't feeling like presenting or they don't have stuff, no worries whatsoever. I do not want to enforce this idea that the meetup is driving, like the only thing that's driving your project or anything like that, or that you have to get stuff done in time, anything like that. Okay, so other announcements. Let's see here. What do I have? Oh yeah, so the CT-CFT working group panel. So this is more on like the organizational side, but I was part of a panel a few weeks ago for the Rust cross-team collaboration fun times meetup. And so this is where a lot of working group leads and team members participate or get together and sort of give talks on more of the organizational side behind these working groups and interest groups and teams and everything like that. But you can go check out the VOD on YouTube. And so if you just look, well, I mean, I guess if you look up Rust CT-CFT, it'll probably come up as one of the more recent ones. And so that was pretty cool. I got to talk with some people from the embedded side of Rust, the crypto side of Rust, and machine learning side of Rust, and sort of compare and contrast what our like the bigger working groups are doing versus like what some of the interest groups or like the smaller, like more recently organized ones are up to. Newsletter. Newsletter is almost out. We are just finishing up editing some of the last few sections, getting so editing last few sections and then just editing the entire thing overall. So I imagine it will be out in like the next day or two. There's some cool stuff in this one, so definitely don't miss out on reading it. Rust Graphics Meetup, I already mentioned this, but go watch the talks on YouTube. If you go to, I rebranded all the stuff. So what used to be the Rust Gamedev Meetup on Twitch is now it's just Rust Gamedev. That's the username, and the same thing on YouTube. It's not the Rust Game Development Meetup, but it's just like the entire Rust Game Dev generally working group. If people have YouTube videos they want to put up, hit me up. Right now I've just been using it for these meetups and then the graphics meetup. Other people have just expressed interest in potentially hosting their own meetups and stuff like that, and I'd love to work with people on that if they want. Someone mentioned like a UI meetup, and I'm sure there's a lot of other stuff that could go on here. I didn't. 1 second, let me refresh this. Oh, very cool. So discussions on working group. Oh yeah, so I just added like the discussions functionality to the Rust Gamedev working group repo, and Torosh and myself, we had a small meeting. We were discussing an inner engine asset library. So for example, you have like the Unreal asset library where you can go and get assets for your Unreal projects, but we were talking about what it might look like to have one specifically for Rust, but like just several like many different Rust engines. And so there's a discussion on that. It's a pretty great discussion, actually. We've had Cart from Bevy sort of mention why it wouldn't work as well on the Bevy side of things. But then on the other hand, what it could look like maybe, well, Cart didn't discuss this, but I'm interested in what it could look like as plugins to different Rust engines. And so maybe if one core team was working on this asset library and they manage the extensions for other teams and stuff like that. So that is the end of the meetup, or is it? We actually have a newly released Tan video, and whenever Tan drops a Rust video, you better be sure I'm playing it on the Rust stream for content. So I don't actually have, I don't have it pulled up yet. I'm gonna go back to the schedule for just 1 second, but we'll be back in just a minute for anybody who wants to watch along.
like this is my